All right, we got another problem here. Particular element with a unit cell length of 5.21 angstroms, and this element packs in a face-centered cubic lattice. What is the radius of the element? All right, so in some of these problems, they're not as common. They can give you a unit cell length and ask you to calculate a radius. For this type of problem, we actually don't need to do much in the formula. We just need the denominator. All right, so it has a unit cell length, A naught of 5.21 angstroms. All right, so we're going to say, let me get the pen. So A naught is 5.21 angstroms. Was that the right number? Yeah, 5.21 angstroms. And it's face-centered cubic lattice. All right, face-centered. So what's face-centered? Face-centered is going to be this formula right here. Okay, notice how all of these, and I pointed this out in the first video about density, all of these, this one is simple cubic, this is body-centered, and we're going to use face-centered right here, but all of them have a different denominator expression. All right, so here's the idea. All right, A naught is the unit cell length. We're assuming a cubic unit cell for pretty much all of these, okay? So A naught is basically the length right here, okay? It's the length. Since all cubes have sides that are all the same length, each one of these is A cubed. And so if I were to want to find the volume of the unit cell, which is usually abbreviated V sub UC, V for unit cell, the volume, I just take the A naught and cube it. All right? Now, remember what density is. Density given by rho, or D, is the mass per unit volume. Okay? So it turns out that technically for the density, this is the volume of the unit cell down here. So what's my expression for the volume of the unit cell? Well, the denominator is 2r squared to 2 cubed. So if my volume of the unit cell is the quantity 2 squared root of 2, I'm going to put those together, r, quantity cubed, okay? And that's just equal to, since the VUC is equal to A naught cubed, then that means, taking the cube root of both sides, that 2 square root of 2r is equal to A naught. Because all I'm going to do is take the cube root of every one of these. All right? And that's going to leave A naught, which is the unit cell length, is equal to 2 square root of 2r. All right? So if I'm looking in this problem for the radius of the element, all I'm going to do is do this. So when you have a problem like this where all you're looking for is the radius of the element and you have the unit cell length, that is not what I meant to do, then it's pretty easy. You just use the denominator's expression. All right, so let's go ahead and do that. So basically 2 square root of 2 is 2 to the 3/2 power, and that's times r is equal to A naught. Okay, so r is going to be equal to A naught divided by 2 to the 3/2 power. All right, so I'm going to plug that in, and we know A naught is going to be 5.21, and we're going to divide that by the quantity 2 to the 3/2 power, or I could even type that in as, I'm using a calculator, 2 to the 1.5 power. And I get that the radius, r, is approximately, let's round this to 1.84 angstroms. And that's a pretty reasonable radius. If you get a radius, by the way, that's less than about 0.9, no rough cutoffs. If you're getting a huge radius, like in angstroms, in like 5 or 6 or 7 for the radius of the atom, then you may want to go back and check. All right. So this is definitely a reasonable answer, so I'm comfortable sticking with that. All right. So that's how you calculate the radius of the element if you're given the unit cell length. You actually don't have to go to the trouble of using the whole density formula. All right. In the next video, we're going to cover another density calculation. Thank you.